In this video, we're going to be dividing decimals. First, a little vocabulary. We're going to be asked to evaluate some statements here, which are, it means to find the value of an algebraic or numerical expression, or simply a matter of get the answer. We also have the term expression. That's a mathematical phrase that contains numbers, operations, and or variables. The key here is that it does not contain an equal sign. If it has an equal sign, it's called an equation, and we're not dealing with those right now. A simple expression, 3 plus 5 minus 7, or 3x, or 3 times x, plus 5. Order of operations always apply, but as long as you don't have an equal sign, what we're looking at is an expression. And the final important vocabulary term we're going to use is quotient. Quotient is the answer to a division problem. If you remember, product is the answer to multiplication. Quotient is the answer to division. So now that we got those vocabulary terms out of the way, let's go ahead and get started with some division of decimals. Now we've got a note at the bottom here that says to remember that the first number in the division problem goes underneath the division sign, and the second number goes outside the division sign. We have 4.68 divided by 9. So as we write this out to do our long division, we're going to have 4.68 divided by 9. Now here's the secret when it comes to dividing decimals. We don't need to worry about that decimal until the end. It's going to work just like dividing integers that you already have plenty of experience in. So tell you what, let's do this for this problem. This decimal, I'm going to get rid of it for now. But so I don't forget where it is, I'm going to put it here, where the answer is going to go. And you'll see why we did that in just a minute. Okay, let's take a look. Does the number 9 go into 4? It does not. So we move over to the next space. Does the number 9 go into 46? Certainly does. 9 times 5 is 45. So I'm going to go ahead and put the number 5 here. We have 45. We're going to subtract those numbers. 46 minus 45 is 1. And we bring down the 8. And 9 goes into 18 twice, which is 18. Remainder of 0. So look at what we have up here. It's the number 5, 2. But where'd that decimal go that we moved? Remember, it was originally right here, and I just moved it straight up. 0.52, or if you prefer 0.52, is the answer. And the moral of that story is just like when we're adding and subtracting decimals, if you remember, the location of the decimal is something that is always tracked vertically. You always line it up one on top of each other. In a division problem, we do the same thing. So let's do another one. Negative 100, excuse me, I'm already thinking about it without the decimal. Negative 13.2 divided by 2.2. Okay, let's go ahead and look at this. Oh, there's a reminder. You cannot divide by a decimal. You must remember to move the decimal to create a whole number on the outside of your division sign, and then you can move the decimal the same number of spaces underneath the division sign. So what does that mean? We're going to start with there's a negative and a positive here. Are you okay with us ignoring that for the time being? I think it's important. Hey, let me check with you really quick. When you divide numbers and one's positive and one's negative, what's the answer going to be? The answer is going to be negative. I'm going to put that up here. A little negative sign in some parentheses. I'm going to come back to that later, so I don't need to worry about the negative and positive anymore. I already know what the answer is going to be from that perspective. We have 13.2. 13.2 divided by 2.2. We can't do it this way because according to what this says down here, you can't have a 2.2 on the outside. So we're going to go ahead and move that decimal point one place to the right and move that decimal point one place to the right. That's going to give us 22 into 132. There's that number I slipped up and said earlier. So let's take a look. Does the number 22 go into 13? It does not. So we'll need to see how many times the number 22 goes into 132. Now, since we're doing this without a calculator, we're going to need to do a little bit of thinking. We'll get a guesswork that's going to be involved. But how many times would you say 2 goes into the number 13? Well, 2 is going to go into 14 7 times. 2 goes into 12 6 times. Let's start with 6 and see if that works. If it turns out we made a mistake, we can always go back and fix it later. But I'm going to try and multiply by 6. 6 times 2 is 12. Carry the 1. 6 times 1 is 12. Plus 1 is 13. No remainder. I got the number 6. What happened to the decimals? We don't even need to consider them. The answer is 6. Wait a minute. Am I leaving something out? Can't forget that. We learned that the actual answer when we're all done is a negative number. It's a negative 6. It's a good idea to check through everything, make sure it all worked out. And even though I started at the beginning of the problem identifying that it's going to be a negative answer and I didn't have to think about it, got to remember to bring it back in when you finish the problem. So many mistakes are made that way. I don't want to see you doing that. In our third example, we're going to be looking at using substitution to set up our expression in order to evaluate it. We're saying to evaluate the expression when x equals negative 6.34, and we're doing x divided by negative 0.26. Okay? So if I were to write out the problem, we're going to say that we're doing negative 6.344 divided by negative 0.26. Now, just like on the last problem, I don't want to have to worry about these negatives right now. It's just going to complicate things if I don't need to. So let's just go back to our rule. We have a negative divided by a negative. The signs are the same. Negative divided by negative is a positive. I'll put a little sloppy looking plus up there that we'll be able to reference later. I don't think we're going to forget about putting a positive on there because if we leave it off, well, we assumed it's positive anyway. So let's set up our division problem. We're doing 6.344 divided by 0.26. Now, just like on our last problem, we cannot have a decimal out here. They're okay inside here, but you can't have them out here. So let's move it 2 spaces to the right, 2 spaces to the right. The problem that we're going to actually evaluate, or the expression, is we're going to divide the number 26 into 634.4. And let's go back to what we did on that very first problem. I'm not going to erase the decimal point this time, but I am going to go ahead and vertically place it right there, because I know that's where it's going to go in the final answer. All right, let's begin. 26 into 63. Well, I know 2 goes into 6 3 times, but with that 6 sitting here, I strongly suspect that maybe doing 3 times might be a little bit much. So let's go ahead and do 2 times. Let's see how that works out. And 2 times 6 is 12. Carry that 1. 2 times 2 is 4. Plus 1 is 5. We have 52. Subtract those numbers, and you get 11. 11 is smaller than 26, so I know that we made the right choice, choosing 2 instead of 3. And now we'll bring down the 4. 26 into 114. Well, I know that 2 goes into 10 5 times. But 5 is an awfully big number to combine with the 6 that's over there. So instead of 5, again, I'm going to go a little bit lower here just to try that out. Let's try 4 times. 4 times 6 is 24. Carry the 2. 4 times 2 is 8. Plus 2 is 10. We have 114 minus 104, and that's going to leave us with 10. And then we'll go ahead and just bring down this last 4. Well, almost running out of room. This problem's going to take a few steps, but did you notice what I just noticed? We have a 104 right here. We already know how to make a 104. 26 times 4 gives us 104. So we're going to go ahead and just put that there. And we know that that's going to cancel out. We're all done. So the answer I'm getting is 24. There's the decimal point. 0.4. What's our sign going to be? We already looked at it up here. It's a positive 24.4. So we don't need to do anything else to it. This is the final answer. 24.4 is the answer you get when you divide negative 6.344 divided by negative 0.26. Now let's apply what we've been doing in the context of a word problem. Olivia drove 378 miles on 15 gallons of gas. How many miles per gallon did her car get on her trip? You might be thinking to yourself, hey, there's no decimals in here. You're right. There aren't any yet. But let's take a look at how we'll handle this. We're going to do 378 miles divided by 15 gallons of gas. Seems simple enough to begin. We're going to do 15 into 37. Well, 15 goes into 37 2 times. (37 minus 30 is 7. And then we'll bring down the 8. And we have to see how many times 15 goes into 78. Well, 15 times 5 is 75. Remainder 3. We don't need to worry about remainders anymore. Let's get a real answer here, shall we? I'm going to introduce a decimal point there. And then we can just go ahead and put zeros. In fact, we can put as many zeros as we need. But let's just start with 1. And I'm going to bring that 0 down just like I would with any other division problem. How many times does 15 go into 30? Well, 15 goes into 30 2 times. And now we've got it set up just fine. But there's something we need to remember to do. Since we introduced a decimal point here, just like on our prior problems, we need to make sure that vertically that decimal point is in the exact same spot. So how many miles per gallon did Olivia get on her trip? She got 25.2 miles per gallon. Now sometimes we're not going to get an answer that is as nice and neat as it was with our previous problem, and sometimes that's not even an issue when you get that. Here Coach Pryor is saving $25.25 each week to buy new goals for the soccer team. Each goal costs $850.75. How many full weeks will he have to save in order to purchase one goal for his team? So what we're going to need to do here is the number 850.75 divided by 25.25. And like we learned earlier, it's okay to have a decimal point here, but it's not okay to have a decimal point outside. So we move 2 hops to the right, 2 hops to the right. I already know this problem's going to get kind of big, so I can go ahead and erase what we're having here. What we're actually going to be doing is the number 2,525 into 85,075. Seems like pretty big numbers, but we're going to be okay. Remember, we're just going to do 2,525 into 8,507. We know that 2 times 4 is going to give us 8, but with all these 5s and then the 2 there, I'm thinking if we go all the way for that 8, it might be a little bit big. So let's go ahead and try a 3 instead. 3 times 5 is 15. Carry that 1. 3 times 2 is 6. Plus 1 is 7. 3 times 5 is again 15. Carry the 1. And 3 times 2 is 6. Plus 1 is 7. We have 75. 75. Subtract. 7 minus 5 is 2. 10 minus 7 is 3. 14 minus 5 is 9. And 7 minus 7 is 0. So it looks like we have 932. Bring down the 5. And how many times does the number 2,525 go into 9,325? Now I already saw that 3 times this number gives us 7,575. And doing some quick mental math, we can at least estimate that the difference between these two numbers is less than this. So we're only going to be able to fit 3 more in there. So we're going to do 75, 75, and subtract it. 5 minus 5 is 0. 12 minus 7 is 5. 12 minus 5 is 7. And 8 minus 7 is 1. We have 1,750. Just like the last problem, let's take it a little bit further, see what happens. We're going to do 0.0. Bring down the 0. And we want to know how many times 2,525 goes into 17,500. Well, let's see. I'm going to go with 6. See how that works out. 5 times 6 is 30. Carry the 3. 6 times 2 is 12. Plus that 3 is 15. Carry the 1. 6 times 5 is 30. Again, plus 1 is 31. Carry the 3 over. 6 times 2 is 12. And 12 plus 3 is 15. Running out of a little bit of space here, but I can tell you we are not going to get 0, obviously. And having worked this problem, I also know that we're not going to get a nice pretty decimal. It's going to be something that's going to repeat ad infinitum, or to infinity. But we don't really even need to consider that. How many full weeks is he going to have to save? We don't know anything about how Coach Pryor is saving it. We just know that maybe it's at the end of the week that he gets $25.25. If he only works a partial week in this saving concept that he's doing, is he going to get part of $25.25? I doubt that seriously. Well, we know that if we do 33 weeks, he's still going to be short 1,750 points in there. Okay, not quite enough money to make it. So the easiest way to look at it, how many full weeks? Well, he's going to have to work 34 weeks. He'll have a little money left over, which I'm really happy with him about. But 34 weeks is all he needs in order to save up enough to get that goal that costs $850.75. And I hope you found this series of problems helpful when it comes to dividing decimals.